So we're going to take a look at something called Radian Measure in this PowerPoint, in this lecture presentation. And I want you to think about to when you were learning how to measure units in your previous school year. So think about back when we learned about the difference between inches and meters. And there was a difference in the measuring system because meters is a part of the standard measuring system that's used worldwide when we're working with scientific information. And radians is the mathematical equivalent of that. So degrees kind of is like inches. It's a convenient measure. It's very easy for us to visualize. But in order to do a lot of the calculations in mathematics, we need to actually use radian measure. So what is a radian? An angle with its vertex at the center of a circle. So here, kind of like the coordinate plane is drawn here, the origin here would be the vertex of my angle, and it intercepts an arc on the circle with equal measurement. And the length of the radius of the circle has a measurement of 1 radian. So what we're talking about here, notice this is little r over here, and this measurement of this theta is also little r. This is because radians goes back to the idea of a circle. So this would be similar if it was in degrees. If this was 60 degrees, this arc would be in 60 degrees. But if you think about arc length, degrees isn't really a way that we measure arc length. We tend to measure arc length in inches or other units. So we're going to use this radian measure to be able to do those kind of things. So it's still the same idea. To convert between degrees and radians, if you're given an angle in degrees, you're going to multiply by pi divided by 180. Here is the thing, guys. The majority of the time, you don't actually multiply by 3.14. We don't actually do that a whole lot. The best way to do this is to use the Web 2.0 calculator. Take your angle, divide it by 180, and it will give you a fully reduced fraction. So let's say your angle is 60 degrees. You're going to go to Web 2.0, you're going to do 60 divided by 180, and it's going to give you that nice reduced fraction of 1/3. Now we can account for the pi, so I would do 1/3 times pi, which is pi over 3. We don't typically tend to use decimals with radian measure. We tend to prefer it to be that nice fraction with the pi still hanging out on the top. If we want to convert from radian measure to degrees, we're going to flip that measurement and multiply by 180 divided by pi. So if I had pi over 3 times 180 over pi, the pi's are across from each other and they would cancel out. And you would have 180 divided by 3, which is 60. So those pi's are not really values you're going to be entering into a calculator. We're going to be working without those. So here's some examples that I did. So if you want to do this with me, go into the Web 2.0 calculator. I've posted a couple links to it. And to enter this expression, you would just do 45 divided by 180, and it would tell you that's 1/4. The pi always gets popped into the top, so it'd be pi over 4. It doesn't matter if it's negative. To do this in a calculator, you would do negative 270 divided by 180, which would give you negative 3/2. You pop the pi in the top. We're not multiplying by pi. We're not multiplying by 3.14. Again, if I have 249.8, this is the case because we already have a decimal. We would want to go ahead and multiply by pi over 180. This is one of the only times we're going to actually do that because I have a decimal. When I multiply by pi and I get a new decimal, it doesn't really change the idea. Here, I don't have decimals, so I don't want to create them. And this is the reverse. So when you're entering this into the Web 2.0 calculator, you're going to enter 9/4 times 180. You're not going to enter the pi because we know they cancel out. And that gives you 405. Same thing here. You're going to do negative 5 divided by 6 times 180. You're going to ignore the pi's because they cancel out, and you're going to get negative 150. This one is already in decimal form, so you're going to actually enter the pi in Web 2.0. There is a symbol for Web 2.0. Do not use 3.14. You have to use the pi symbol. So I'm going to multiply that by 180 over pi, and I'm going to get my decimal. This is coming from the previous section where we did degrees, minutes, and seconds. I just wanted to review. You could do your 5 divided by your 5 and convert that over to minutes, and you would get 30 minutes. If no angle unit is specified, what does that mean? That means if you don't have a degree symbol, it has to be in radians. Whether or not you see a pi doesn't matter. If there's not a degree symbol, you're in radians. So here I have degree symbols. So I know these are degrees. I can convert these over to radians. Notice the pi is the exact value, but when I take the pi out, it's an approximate value. This is why I said unless you have a decimal in your degrees, you don't want to actually do the calculation with pi because you want an exact answer as much as possible. So what I've done is this is really helpful for you to take a quick screenshot and print it out. These are all of the angles we talked about through reference angles. These are their radian measures. So you've got that nice conversion of all of your special angles into radians because for the most part, we find it difficult to visualize what is pi over 4. That can be really odd to visualize. So that's going to be 45 degrees. If you have this printed out, you can kind of quick reference it, and it's going to help you move a little bit quicker through those homework assignments. So this would be finding the reference angles from last week, building upon it. So I have tangent of 2 pi over 3. I can either go back to my visual and relate 2 pi over 3 to 120, or I can convert it using the conversion factor, which gives me tangent of 120. Now remember, when I'm looking at tangent at 120, it's in quadrant 2. So I'm going to do 180 minus 120, which is going to be tangent of 60. So I'm going to go to my chart. I'm going to find out the tangent of 60 is the square root of 3. It's in quadrant 2, which means my tangents are negative. So it'd be negative square root of 3. Same thing with sine of 3 pi over 2. I can either revisit this or do the conversion myself, and I get 270 degrees. 270 degrees is right smack on the axis. Utilizing that information, sine is my y value over 1, so that would be negative 1. Same thing here, converting cosine, 4 pi over 3 to 180 would be 60, would be my reference angle, and it would be negative due to quadrants. So it's everything you've already learned, it's just using a different name and measurement style for the angle.